Hey, the human cannonball. Alright, now this one's going to involve some angles. Alright, so this guy is being launched 24.6 meters per second at an angle of 50 degrees above the horizontal. And it looks like we want to know how far this guy goes. We want to know that distance, that horizontal distance. Alright, so we need to know, for the horizontal distance, we're going to need to know the horizontal velocity and the time. So the horizontal velocity we know is 24.6 cosine 50 degrees times time. That will be our answer. Okay, so the key now is to find out the time. How long does this guy spend in the air? Well, for that we need to know the initial velocity. So that's 24.6 sine 50 is our initial vertical velocity, and that's our horizontal velocity. We know that when he reaches the halfway point, the velocity is going to be 0. So let's find out how long that takes, and then we'll double the time for his return to the ground. So 24.6 sine 50 over 9.8. And let's make both of those negative, because this should be 0 minus that. Right, basically I'm doing v final minus v initial in the vertical direction divided by acceleration equals time. Which is just a rearranged version of this equals acceleration times time. But I'm going to go ahead and divide by acceleration, which in this case, free fall problem, so this is gravity. And in my calculator, sine 50 divided by 9.8. For time, I get a 1.9229, multiply that by 2 for the full trip. Okay, so this is twice the time that I solved for here. So this is my full time that I'm going to use over here. Sorry if that's confusing. Let's see. So let me call this the time to the top, and we'll call this the time to the ground. Alright, so it's this time that I'm going to use over here. Okay, multiply that by my horizontal component, the 24.6 cosine 50, and that gives me a distance of 60.8 meters.